here we know what the problem now is that I'm on the wrong computer architecture to execute these instructions to install BWA from the Biocoder package. The good news is that someone for the Biocoder community is already working on this, and hopefully the next couple of weeks this will run. So the idea was to familiarize ourselves with the code environment, and what I've done here is just to copy a couple more commands that we can make use of. I did already sort of illustrate this earlier on, that if you call coder and minus help, it will show you the help pages, and it's very well documented. But the documentation can be quite tight sometimes, and I imagine they're trying to strike a balance between making documentation that useful, but at the same time not wanting to write paragraphs and pages of the documentation. So if you want to list packages that are installed in your current code environment, you can simply do coder list. It'll show you packages that are already installed in that environment. And that was a question, she asked, how do I know what's in my environment? You may have lots of tools, and you can imagine, you're gonna just continue installing, and sometimes you don't know what is in your environment. And the info -h, I think it's all, will display information about the code installation. So that can be useful if something is not working, or you need to do some debugging, or you want to share that with another developer or a colleague. And you can search for documentation. In this case, you've got a single quotes prepended with the card. I think that's what you call this interesting symbol here, over here. So it's looking for things that start with doc. The same thing you do using the grep command. Yeah, I'm sure somewhere in the background it's actually probably using grep. And if you want to update, as you mentioned, packages get updated all the time. So you can update a specific package. And sometimes when you do this, you're going to see a long list of transaction changes. And in some instances, it also warns you that maybe updating that package might result in downgrading a specific or a certain dependency. And therefore, it's assuming that you're cool with that, or that works for you. And you can uninstall a package simply by calling coder remove, and uninstall that package, which can be pretty useful. So I'll list all this, and everything will be on our course material. But if you want, we can try this in your code environment, and can really be useful to navigate. I wanted to share us something, and for us to do it, I think I'll copy this. I was meant to share this on our Google Doc, that we can get to this nice tutorial. It's still experimental though, but before we get there, maybe you may want to see, how are things and packages configured or listed. So this is the contents of an example environment file. He asked, so for example, if I want to share my environment, is it okay to copy the contents of my end folder and share that with someone else? And while that might work, I think depending on the exact configs, it's don't want to do that for simple reason that computers and machines differ quite a lot, and how binaries are also built can differ substantially. So this is a tool for those that have worked maybe with SARS-CoV might be familiar with this tool called Pangolin, and it stores all its dependencies in a YAML file. So if you want to install this tool, it's written in Python. It's available on Biocoder channel. And the first thing you see there is a name, Pangolin. The channels, are listed, and the dependencies, and if you look at this file, it has a specific format, and I think they call this format YAML or YAML. And I think files have evolved, config files. I mean, we've had XML, representing configuration files, and I think what we have here is YAML. I don't know what exactly stands for, but some people say yet another markup language, and others argue YAML. What is it? Yeah, YAML yet another markup language. YAML is yet another markup language or something. Who knows what Linux stands for? What does it stand for? Linux. Yeah.
Linux is Unix.
What's that?
I thought it was just Linux is Unix. Because of Unix.
Yeah. It's recursive. It simply means Linux is not Unix.
Oh.
It's recursive for Linux is not Unix. Okay. For good reason.
At the time, Unix, when Linux was released, at the time, Unix was copyrighted software.
Yes.
You couldn't copy it.
Yeah, you couldn't copy it, and the licenses were prohibitive and could only be funded by big corporations. And Linus Torvalds, decided to rewrite most of that kernel and port it to machines, portable machines. And therefore, he decided to call it, Linux is not Unix, because it's not exactly Unix, but it's POSIX operating system. Okay. So we're just gonna go through this tutorial, and it's if you like it, again, you can go through it yourself. So I'm just gonna try and copy.
By the way, Vicky said it's human.
What's that?
Human readable data serialization.
Yeah, it's a serialization format. So I want to copy the URL from our share folder. So I'll copy it to the very bottom of this page. So I've copied it on the shared Google Doc. And it's a much broader tutorial, and some of the aspects that in this tutorial we covered it. It's written for data scientists, so the set of packages that they have recommended here are sort of data science centric, if I could use that, but I don't think that should be an issue with us. I think the core concepts here are all about this environment YAML file. And we can just go through, read each of these, but I will just try and summarize what they're doing there. So when we're sharing environments, really, what we want to do is to share this environment file, and every sort of code environment does have this file. And as I mentioned, in this case here, they're showing that there's a new N file, environment, which is machine learning in this case, has certain dependencies using Iron Python, Matplotlib, Pandas, Python, and scikit-learn, which are all very machine learning packages if you want to use them. And it does list all the versions. Let me see. But the key thing is, how do you generate it? Okay, so you're within your environment, and you want to share that environment with a colleague, or you want to share it with your reviewers for your paper. You did all your bioinformatics analysis, you created this wonderful code environment, you created all your dependencies in there, and therefore you want to share that file so that somebody can recreate the environment. So the command to do that would be coda and export, and then name of the environment. If you do that, it's going to output this in your standard output device, or TTY, which is your console or your terminal. Let me see if I can do that. Yeah, here we go. I just ran that previously in this environment. We don't have anything in this environment as such, but you can see that it outputs the contents out here, including the channels. So if, let me see if I can do something here. Could activate DWK, and I know things will not work because I need, but there we are. I'm gonna install a package that I know will work. Maybe let me see if Python can work here, which is a different version of Python. Okay, Python will install. So I'm just going to install it here. And everything running in parallel. Hit the tail and press any button except the sound button. Any button except the sound. Where's the button? So that's done. That means that we can run this command, and now you can see that the output is much longer than it was because we just installed a package called IPython, and it doesn't just store the IPython package; it's actually telling us all about all the dependencies associated with that package. So what I might want to do is to store this file somewhere, and I can copy it. I'll be tempted to just do this, redirect that to output file. But Coda does also give us a way to specify a name just using the command over here. So you can specify --file environment.yaml. okay, or YML, okay. So let's see how that would look like. So that's done, and then what we're gonna do is that if we do that and we give a file name, so it's very important. One, the file has to be an environment file, but you have to be sure that while you're writing it, you're not replacing an existing YAML file. Okay, so that's something to be aware of. You know, you give it a name. That's how it's spelled. Right now, okay. And that gets see that I got a file here, you know, that has been created in my base home directory. Okay. Another way to do this often is, you know, I think you can do this, but you can also, you know, do, because this is output into a standard output, I can redirect this output to another file, which I'm just going to do this here. I'm not supposed to do that. And again, you can see that I got my file there. And if I do less environment 2, it has the contents. Okay. So, and that's the file then I would share with someone, and it contains all my dependencies for this particular environment. So you can update your environment file, and there's quite some bit of description, so I'm trying to move between the two screens. And yeah, that's what we just done here. There's quite lots of documentation. So the idea was I'll introduce this, and if you like, you can go through this tutorial this afternoon and learn how to install or rather share these environment files. So as an activity, I wanted us to, you know, go through that, and if you got a problem or a concern, you know, you can raise your hand, and we can sort of walk through the issues. I think the one here, you don't, yeah, I mean, you can if you fancy this, but it's not necessary. All I wanted us to cover was around up to this point here. But this is quite some bonus, you know, if you're familiar with the Jupyter analysis. It's quite popular, particularly within the machine.
We get some more sticky notes prevented to practical.
Okay. Yeah. You can get Jupyter. It's quite popular, particularly within the machine learning statistics community, because, you know, you write code and, you know, you've got a really fantastic environment that allows you to, you know, work quite easily. So yeah, so I'll leave it here, and I think that's all we're gonna cover around Coda, mini Coda, and working in virtual environments. Peter says he's gonna bring a practical, and then tomorrow we will cover Docker and containers. Okay. Yeah. And I'll try and paste a couple of materials as well. Yes, please. Yeah, I put it in the shared Google folder at the bottom. Yeah. It's in here, in this file here. It's in. So I'll try and update it so you can have a look, and if you just walk through it, you know, it's quite nice. And if you like, you can actually go all the way to you know, the start of that course. Yeah. And you can see that we've pretty much covered what this course would be all about, other than for this bit about GPU dependencies, which I think is nice, but you can go through that. It's, GPU work is particularly important if you're in machine learning environment. And how to abstract that, we present that for NVIDIA GPUs. How many of us are within an environment that has this sort of NVIDIA high-end GPUs? V100, A100, RTX 5036 and above. Yeah. Which one do you have?
I'm not so sure, but I think it's RTX. But it's the rest of
The numbers. So the data center level sort of GPUs are sort of the, I think, in my opinion, starting the V100 upward to HGX, whatnot. Those are real fascinating things. So I think, and what we've done, I think, is most about this, and you can walk through this. It is very data science centric, so the installation of the packages and so on around the data science, and we can, but it's no different in terms of, you get to the concept, and I think we have covered the core concepts and how to then share our environments. But as you mentioned, Coda has, it's not everything, and then tomorrow we'll look at another tool, yet another tool that we can use to make and be more reproducible and get closer to actually really sharing computing environments. Right. So I'll stop there and wait for Peter to give us some practicals.